So, a little bit about myself. I'm more of a software engineer. So when you're a software engineer, you like to build products, and a lot of time you come to realization that,
Just have a little closer.
hello.
Maybe this might be better.
There you go. Okay, yeah. So when you program a project, you come to a realization that data is everything. So you build, like, say, for instance, your first SaaS, you want to write, some script that maybe go through the internet to grab some data ethically. So as you're doing that, you realize that there's a lot of factors that stopping you from getting the data. And that when I start getting more into networking, to look more into it and to figure out what it is. So, okay, so here's one of the examples that I found. So I run like a small software as a service company. So when you have, a software that allow people to buy or subscribe, you realize one thing that there's a lot of bad people. So there's one of the examples. So this guy, he do something called, I think, credit card shuffling. So I don't know where he get all this credit card from. So you have like a lot of people, name and credit card and, all the data. And then he trying to subscribe to a lot of my servers to make sure, which credit card works. So one thing that he forget to hide is his email. So he use the same email for pretty much every single credit card. So my system kind of flagged it, and then I look into it, and then we go through all of these IPs, and then we see a lot of residential IP, and be like, okay, that would be some fun topic to talk about in Bsides Seattle, but residential IP. And so I work with Stripe a little bit to figure out who that is, and I think Stripe got him handled, and that's pretty much it. So yeah, let's talk briefly about residential IP. I believe that they appear around 2014, and it grows significantly in recent years. And the thing about a lot of this residential IP is that the lack of transparency. So the companies do not disclose the exit node and how they even get to the IP in the first place. Some claim to have millions of IPs, and just some simple Google search going to show you millions of results, like all of this company where you can subscribe and use that for whatever purpose that you want to do it for. So now the quick question, how do they do it? How do they grab your grandma's IP and use it at their own IP? So there's a lot of ways that they can do it. One of them is, say for instance, you buy a free VPN, or they have like some kind of bandwidth sharing thing where, hey, if you do this, we're going to give you some money. And usually when a lot of things that are free, they aren't really free, you are the product. So yeah, so that's essentially how I kind of found out how they do it. But essentially, they don't really disclose it. So it's really hard. A lot of time they also could be hacking. And once they have like a backdoor or certain kind, they would be able to use your IP address. So yeah, like I said before, why do you use residential IP? So if anybody in this room ever trying to scrape something on the internet, you realize that a lot of this website, they have a pretty good detection in terms of like, if you use like a well-known VPN to shuffle your IP address or the data center IP, then a lot of websites have like a pretty good detection. They would block you pretty much immediately. So one way that you can scrape, which is not really recommended to do if the website do not allow scraping, is through residential IP. So the server would essentially, it's hard to tell if that's like, you try to scrape the website or you're not trying to scrape the website. So yeah, and you always can do a lot much worse with the residential IP than just that, but scraping is something that I know pretty well. So that's what I give an example of. So yeah, let's talk a little bit about detection. So as I was going through this and kind of play around with my server, and just run a few tests, and I can somewhat say that there are a few ways that you can detect it. Although a lot of them aren't, it's really hard, like these people are really good at like hiding their stuff. So it just like the general way that you would be able to do it. And every of this method have a lot of drawbacks. And yeah, and let's talk more about the TTL. Wait, where's the slide? I missed a slide, hold on. Okay, here it is. Someone accidentally deleted it. So time to live analysis. So the time to live encode how many hop packet has traveled by decremented by 1. And different OSs have different starting TTL, which can generally see by this equation right there. Observe TTL is in initial, subtract by hop count. And sometimes residential traffic and proxy have like a different network path with, like different hop counts. So for instance, if you receive a package with the TLR52, most likely it's gonna be the initial 64, and it's gonna be like somewhat like 12 hop. And then you can maybe build a system with have like a baseline. If the same city gonna be like around 12 hop or something like that, and you can use that to somewhat detect the anomalies. And you can also make sure like the same IP have some stable TTLs. You can, I guess, like build somewhat of a stateful table for all of that. And the way that you should be able to do it is to use eBPF, which essentially think of eBPF as like one of those programs where it runs safely in the kernel without modifying kernel modules. And but the one drawback about this is if you sometimes they use BGP and the ECMP, which the path going to be different and going to be weird, and also mobile network also would have a really weird path. So it's really hard to like tell from TTL alone. And so another somewhat of a indicator is reverse DNS or RDNS fingerprint. But here's the thing: reverse proxy is designed to bypass this, but you can always use this to make sure that is it a proxy or not. What I come to realization is that a lot of people who use residential proxy also mix with their VPN or any other proxy. So they would use VPN, and sometimes the VPN doesn't work. They switch to a residential proxy and just run around it like that. So it's not like they don't always use residential proxy. So RDNS would be somewhat of a weaker way, but you can always build into your detection system. Just add a few code, and every time it violates a certain law, you just add maybe 5 as your baseline. And another one that is a little bit better, which is JA3 and TLS reuse. So when the client requests, I can do this all the time. So it's essentially like a TSL handshake, and the HTTP request. So the client sends a TLS hello, and they will get an MD5 hash. And it's essentially answer to the question of what kind of TLS client is this. If you use bots or proxy, often you curl Python or headlet browser, it's a lot easier to see. And so the JA4 is just another JA3 improvement, but this slide we're going to go more into JA4 plus. You can also do TLS reuse, because a lot of bot they usually they don't really reuse a session, they create a new session. As somebody who created bots, it's also best to use a new session than to reuse it, based on my experience of pen testing and playing around with this. And now let's look at JA4+. So JA3 is TLS only, it's no longer sufficient. More than detection require multi-layer approach, which is why JA4+ somewhat born, I guess. So here's one of the research that I found online. So they use JA4T and TCP feature, which is your packet side TCP windows. It go across the layer, from layer 3 to all the layer 7. So it make it a lot harder for the proxy or anybody provide the proxy to spoof, because you essentially need to maybe modify the kernel to a certain degree. And as you can see the signature, although this is only 60% effective, so it's not like a concrete way, but it's also a good way to detect whether it's a residential proxy or not. So let's look a little bit deeper into this. So JA4T fingerprint is essentially the SYN, because the SYN packet is the only moment where the client reveal the true TCP configuration. So you can see here, you have a IP header 20 bytes, TCP header 20 or 60 byte, which include option, and the option has MSS, Windows scale second, and all that. And we look more into the MSS here. So let's break down the JA4T fingerprint. So here's an example that I bring earlier, that one of the way that you can see register proxy is by looking at this. So MSS is essentially derived from path MTU, and it reflects the encapsulation overhead, which can be used by this equation right here. And so since proxy and VPN introduce encapsulation, this reduces the effective MTU. So what they found is that the normal MSS is, like around 1460. The proxy MSS is around 1380 to 1400. And also the option ordering is not standardized, and it's pretty difficult to manipulate without kernel level change. So this can also be used, as a way to detect proxies. And now let's look at more about how you would be able to collect it. Like I said before, eBPF is a pretty new topic. I'm pretty sure it come somewhat recently, and there's a lot of research that going into this, which currently I'm kind of doing. So I don't really understand eBPF to the fullest. I'm just kind of do more research to eBPF. And so since J4T and TTL rely on TCP/IP packet field, this field obviously will not be able to be visible in the application layer like Node or Nginx, which is why you need access to the packet before it's HTTP processing, which is why you bring eBPF into the question, or like the equation. So it would allow real-time packet inspection, and it's essentially pretty fast because there's no kernel module change, or you don't really mess up with the kernel. So eBPF is a upgraded version of BPF, or like the original BPF. I'm pretty sure the original BPF is used just to inspect the traffic and everything in between. And then the eBPF, now you can hook into the kernel. You can actually write a lot of detection, or like a system with eBPF, because you can see like all the calls from the program. But yeah, like I said, the limitation is, obviously there's a lot of limitation. It's hard to really, I suppose, catch if somebody who is definitively use proxy to attack your site or not. You kind of need to use your intuition. Like for instance, when I run my service, I see a lot of this request, and then you look at the logs. You kind of have to use your intuition to like detect whether it's something to worth look into, block, or anything like that. And AI is another tool that you can use, but from my personal experience, human intuition is always a little bit better than AI, since AI use like somewhat of a distribution system, and it's probability, and human intuition is always going to be better, in my opinion. So a few case notable of industry response, as you can see all of this. If you're ever trying to buy a ticket from like a concert, and then all of a sudden you just can't get it because all the bots is getting it. So yeah, the industry trying to work to help reduce the bot, I'm trying to say. So here's the thing. I was going to show you guys a demo, but in doing the demo, I actually linked one of my really crucial IP address that used in my my infrastructure. So I can only post like a redacted version of the terminal. So essentially what I'm showing here is, when you install a VPN, it's really easy for the VPN to use you as an exit node. So you see, this is my VPN. I curl something, and you can see it's my VPN IP, and then I can, use my other computer system as an exit node that uses a VPN to use that computer Wi-Fi, I guess. So yeah, essentially this is what it is. Also, my computer, after working with this, I kind of screw up the routing table. So this cannot connect to the internet except my phone internet. So I can't also show you, because then I would need to configure my VPN to add all the route manually, which is like a pain in the ass. But yeah, but essentially, yeah, but that's pretty much it. But yeah, here you can see I have to manually add a bunch of like routes whenever I want to go somewhere. So, and I don't know how I can reset that, but yeah, it's pretty cool. Like when you run like your infrastructure, I can show you. I can't really show you, but like this is actually my infrastructure that I have. So what's pretty cool is that I own like a SAS24 block public IP. So I just run it in the data center in Chicago, and that's more so of my research project where I would have buy a bunch of routers, switch, co-loaded a Chicago data center, and then just run a bunch of, like, see what's going on. And one of the things when I was doing the VPNs, I linked one of my very crucial IP address for my VPN, which you can literally go into all of my infrastructure. So I have to reenact it. But yeah, that's pretty much it. If you guys have any question, any question? Thank you.
At least in my mind, a lot of these detection capabilities are a little bit more expensive, right? They require, looking at additional layers in the OSI model, essentially
Right.
to identify if the user might be
Right, yeah.
Right. So presumably, if you identify an IP address or some indicator, you're going to store that, right? And then perhaps you have another legitimate user that happens to have a malicious device on their network, so they're going to be clustered
Right.
with that traffic.
Right.
Just based on the IP address. What do you do in that situation, right? How do you handle the risk trade-off of blocking a potentially legitimate user that happens to have essentially malware on
Right.
or happen to be operating an exit node?
Okay, so
I think the risk comes from where you have essentially botnets. Your devices are affected, like IoT devices for example, are affected, and they use your IoT device as an exit node to be able to reach your service from wherever they are. And so how do we want to differentiate and discern whether or not the request is actually coming from a legitimate user, like you said,
right.
it's coming through like an infected device within our home, for example.
Right. So yeah, this is actually like a good question. But it's really hard to do because you don't want to block the IP of the person who legitimately use a website, and there's somebody who literally trying to attack it from that IP. So here's the deal: either you can terminate that session, which is something that I think that you should do, instead of blocking the IP, or if in the greater grand scheme of things, maybe blocking one IP might be the way that you might just have to do that. But generally, I believe should just try to terminate that session if that makes sense. You know what I mean? If that session is like attacking, then maybe I don't know, just terminate that, I suppose.
Got it. So your recommendation is to apply the mitigation specifically to the session that you
Right. Yeah.
provide the signals from, not to
Not.
cache that IP address or
Right.
any other further association.
Right. So that's the whole idea of JA4 Plus, right? You focus on individual, connectivity instead of the whole. You know what I mean?
Right. I think the challenge there, right, is just figuring out how to realize the potential cost of doing that, right?
Right. Yeah.
Pretty strong incentive if you've done a
Right.
maybe sort of computational.
It make it harder for them. Yeah.
To reuse it.
Like for instance, when I run my, I guess scraping thing, a lot of the website they have CAPTCHA, and my Google Gemini solve the CAPTCHA pretty easily. So, you know what I mean? It obviously it cost me a little bit more to use Gemini to solve the CAPTCHA, but they can't really stop me from doing it. It's really hard. Now, for instance, DuckDuckGo, they apply something that I thought is pretty smart. So when you scrape using DuckDuckGo, sometimes it will return the 202, which is it works, but you have to wait for it to process. So when you write a script, you're like, oh, it's 202. Then you skip it. You know what I mean? You never wait for the result. So yeah, it just make it harder. You have to re-request or re-wait until it become 200, and then you see all the data. But yeah, essentially what we're trying to do is to make it more expensive for you to scrape or to attack or whatever. But yeah.
Do you have any visibility into they're sourcing the IPs you've mentioned? You see the free VPN apps or browser extensions. Do you know how popular that is for sourcing IPs compared to hacking IoT devices and things like that?
I'm pretty sure the bandwidth sharing and the free VPN are way more popular than hacked IoT devices, because if you do a simple Google search, a lot of this program they offer incentive for people to do it. And a lot of people, free stuff is good, right? So, or sometimes they give them free crypto if they allow bandwidth sharing, which is, one of the way they can do it. Yeah, you have anything?
No, you got 1 minute.
Okay, yeah. But yeah, that's pretty much it. Thank you for being here, even though I'm a little bit late.